and this is my portion of the presentation. The road I chose is called Bella Cumbre Drive. There is a stop sign here, and here I chose this street with its specific stop sign so I could know if the car started at 0 and I could get a more precise accuracy for my graphs. The land measurement is 198.42 meters and 650.99 feet. I have a video link to the car that I chose. For my graphs, I calculated that he was going 16.5 meters per second, and he did not make a complete stop at the first stop sign. He was coming at a little bit of a velocity before he made it to the stop sign, and since he didn't make a complete stop, he already had that added speed. So he starts here with his 16.5 and he continues going at that speed, and since the graph cuts off, you can't see where he slows down towards the second stop sign but does not make the complete stop. And in my second graph, he does not start at 0 completely or at 0 meters completely. He starts around here and he continues going, and he slows down right around here. Around 12 seconds he slows down, and that's why there's that little curve. In conclusion, the car was speeding because the speed limit was 30 miles per hour and he was going 16.5 meters per second, which means he was going 36 miles per hour, and I did catch a speeder in this project. Thank you.
Hello everyone, I'm Angel, and this is my part of the speeder project. So I did it near a preschool, and I did it following this red car. So looking at the data in our Google Maps picture, we can see that the preschool is located right here. I want you to keep in mind that in Caver Lane, which is located in the middle of your screen, there's a stop sign there. So keep that in mind for future reference. So the starting point for the car was 946.92 feet. That was the starting point in which I started the timer. And the ending point at 0 feet, that's when I ended the timer. The total distance between that is 946.92 feet, or in meters, 288.62 meters. So to start off, what I noticed is that when a car hit the starting point, I started the timer, and I noticed that between 946 feet and 600 feet, it was going at a pretty good pace. I'm predicting that it was going at the speed limit, which is 20 miles per hour. It got interesting because at 600 feet, that's where the stop sign is, right in Caver Lane. So it actually sped up between 600 feet and 0 feet, it sped up. So at that point, it wasn't even following the speed limit. So when it hit the 0 feet, which is the end point, I stopped the timer there. It took the car a total of 18 seconds for it to complete the trial. Looking at our graphs now, we can see that the velocity versus time graph has a x-axis, which is the time, which in this case is seconds. So it took the car 18 seconds to complete the trial. So a total of 18 seconds. That's the x-axis. And in the y-axis, the velocity, the speed limit is 20 miles per hour. So the y-axis is 20. So I started the line right above 2 because the car was already moving before I started the timer. So it was moving already. So instead of starting at 0, I put it right above 2. And then at the end point, which is 18 seconds, we can see that it was still rising in speed. It was rising pretty constantly. So it was over the speed limit of 20 miles per hour. That's why I kept going. Looking at our displacement versus time graph now, we can see that the total displacement is 950 feet, which is the total distance of the trial. And then the x-axis is the time, which is 18 seconds again. So looking at our graph, we can see that the displacement starts at right above 50. I put that because the car was already going, like I said. And then we can see that between 50 feet and 650 feet, we can see the car was rising in speed. then slow down. Slow down near the stop sign, but it didn't stop completely. But right as it hit the stop sign, it sped up. So at around 13 seconds, it sped up pretty fast actually. So to conclude, we have that the 18 seconds, which is the endpoint, we can see that I had a total displacement 850 feet because I stopped the timer right before the endpoint of the total distance, 950 feet. Concluding, we can see the velocity of the car was 47 miles per hour and the speed limit was 20 miles per hour. So the car went double the speed limit, and to add to it, it didn't even stop at a stop sign. So that was my part of this speeder project. Hope you guys enjoyed.
Recorded for my project. This was the distance. It's approximately 717 feet. And this is by the intersection by Franklin across from the McDonald's. And what I did was I measured from the stoplight when the car was stopped and up to where the crosswalk is. And to get the meters, you divide 717 by 3.218 and you get 218.53, which is the distance in meters. So these are my graphs. This is the distance over time graph. You can see that at about, it accelerates for 6 seconds and then continues at a constant rate or coasts for another 6 seconds until it passes the crosswalk. And this is my velocity over time graph. So you can see it starts at 0 and then it increases to around 18 meters per second, or it accelerates to around 18 meters per second and then continues to coast for the remaining 6 seconds. This is my math and observation. So you take the distance in meters and the time and you divide it to get the speed. So the speed is around 18.25 meters per second, and then you multiply that by 60 and then by 60 again to get 65.7 kilometers per hour. And kilometers to miles, to get kilometers to miles, you divide the kilometers by 1.609. So 65.7 divided by 1.609 equals 40.83, and the speed limit was 45 miles, so the car was not speeding.